Hello, Pre-Calc Honors students. Mrs. Myers here with you, and this is our first of 2 days working in Section 5. These are operations with matrices. Now the work that we do here is going to be important for what we do in the next section of the chapter. All right, so don't lose these notes. You might need to refer back to them if you don't recall all the different things that we're talking about here. But it's very, very easy stuff, okay? So I know you're still, some of you taking AP exams are probably just, very wiped out from them. So honestly, the 2 days this week with Section 5 really should not be too bad for you, hopefully, okay? So anyway, there are 4 total operations that we are going to do with operations and matrices. We're going to do 3 of the 4 today because they're very, very short, and we'll save 1 more for the next lesson, okay? So we got our heading here, operations matrices. Okay, so the first one is what we call, it's not really an operation matrices, but it does have to do a little bit with it, and that's called matrix equality. Okay, so first thing to note about matrix equality is that it can only be done with matrices that are of equal sizes. Okay, and then once you have matrices of equal sizes set equal to each other, then what you are going to do is set the corresponding cells equal to each other. All right, so that if we take a look at an example here, okay, we've got ourselves a 3 by 3 matrix set equal to another 3 by 3 matrix. So let's say this one is 4, 5, 4, 13, 15, 3y, 2, 2z minus 6 and 0. And let's say the other matrix is 4, 2x plus 7, 4, and 13, 15, 12, and 2, 3z minus 14, and 0 again. Then, what you want to do is here, I should probably say this, solve for x, y, and z. Okay, then what you're just going to do is take a look at where those variables are and know that the corresponding cells are equal. So here's your x. Well, that is row 2, column 1, so that is set equal to row 2, column 1. So we've got 2x plus 7 equal to 5. So of course it's 2x equals negative 2 and x equals negative 1. All right, now we've got the y variable, which is right here, which is row 2, column 3. So that is set equal to row 2, column 3 over here. So it's 3y equals 12. So here's your y equals 4. And then last but not least is z. So that is row 3, column 2. So then we come over here to row 3, column 2, and we got 2z minus 6 equals 3z minus 14. So of course that gives us z is equal to 8. And that's it. That is matrix equality. That easy. Okay. So now we're going to move on to what we call addition, subtraction of matrices. Okay. And once again, that can only be done with matrices of equal sizes. Okay. And then what you basically just do is you add and subtract, corresponding cells. All right, so if I off to the side of the paper give you a matrix A, a 2 by 2, which is 1, negative 2, 0, 3, and I tell you matrix B, right, is negative 3, 2, and then 4, 1, like that, okay, then I can ask you to do matrix A plus matrix B, okay, which is basically just going to do the addition of the 2 corresponding cells for matrices A and B. So it's just 1 and negative 3 right there, and 0 and 2 right there, negative 2 and 4, and 3 and 1. And then you just show what that is. So that's negative 2, 2, and then that's 2 and 4, okay? But if I was to ask you to do a minus b, well, then you would just show 1 minus -3, -2 minus 4, 0 minus 2, and 3 minus 1. Okay, then you just subtract. Now, of course, addition is commutative, so you really could have done that in any order, a plus b plus a, and that would be exactly the same. But matrix subtraction is not commutative, just like subtraction is not commutative in general, because if you do 1 minus -3 and you do -3 minus 1, you would not get the same answer. So this is going to be 4, then -6, then -2 down here, and then 2. All right, so that is literally that easy for addition, subtraction of matrices. So third and final one for today is what we call scalar multiplication of matrices. Okay, and this is, for example, using these matrices right up here. Okay, if I ask you to do 3 times matrix A, what that basically just means is that every single cell in this matrix gets multiplied by a scalar value of 3. So it's just 3 times the -1, 3 times the -2, 3 times the 0, 3 times the 3, and what does that look like? That is 3, -6, 0, and 9. Okay, so now I can join scalar multiplication, addition, subtraction together. For example, I can ask you to do, well, what I just did before, so 3 times matrix A minus 2 times matrix B. Okay, so I can put that together, and then we would get, okay, so 3 times the 1 minus 2 times the -3, and then it would be 3 times the -2 minus 2 times the 4, and then down here it would be 3 times the 0 minus 2 times the 2, and then here it would be 3 times the 3 minus 2 times the 1, and then just do all those calculations and see what you get. All right, so this is 3 plus 6, so there's your 9. This is -6 minus 8, so -14. And then here this is 0 minus 4, so -4. And this is 9 minus 2, so there's your 7. All right, so easy peasy, I think. That is it for today. We've got one more operation to do, but that'll be for our next lesson. All right, so you got some problems to try with respect to this, and please, I know it's, kind of tedious, but show at least some of the calculations that I know that you know what you're doing. Don't just do everything in your head and not show me any work. All right, thank you very much. Hope all is well. Bye.